Okay, so we're now going to move on to the third and the final part of the algebra chapter. And in this part, we're going to be describing how we can simplify fractions. So we've already talked about this a little bit, and we're now going to go into a lot more detail. So you might think this is quite simple, or you might not see the point in it, but it's actually really important, and it will become clear in the next few weeks why we can use this and how it's great for data analysis. So let's start with a problem. So if we have something where we have a question like simplify 2a squared minus 2ab all over 6ab minus 6b squared. So what can we do to this? Well, the first thing is we can look at the top and the bottom, and we can treat them independently, and we can say, okay, in the top, there is a common factor on both sides of a 2. There's also a common factor of an a. So we can then set up a set of brackets. So how would we get to 2a squared? So 2a multiplied by a gives us 2a squared. Likewise, multiplied by 2a multiplied by b will give us 2ab. On the bottom half, we have something quite similar. We see if we have a 6 on the outside of some brackets, we also have a b on the outside. 6b multiplied by a multiplied by negative b gives us also a minus b. So we've got something we can simplify here. We can say, well, a minus b is on the top and it's on the bottom. So this gives us a slightly simpler expression, which would be this. But we can still go even further. We can actually say, well, what happens if we divide everything by 2? We would get the answer a over 3b. Because 2 divided by 2 is a, and 6b divided by 2 is 3b. And that is our answer in its simplest terms. Okay, so I whizzed through that one. I went quite quick. We're going to go on to something a little bit more tricky now. So what happens if we have the question simplify 1 over 2 a half x squared minus 2 all over quarter y squared plus 3. Well, really, this looks a little bit of a mess and it's quite complicated. So how can we just simplify it? Well, we can see on the bottom here that we have our smallest multiplier, which is a quarter. So how we can get rid of this is by multiplying the top and the bottom by 4. And this will give us something that looks a little bit like, so we say 4 times by a half times by x squared would equal 2x squared minus 2 multiplied by 4, which gives us 8, all over a quarter times by 4, which is 1, so we can just say y squared, and plus 3 multiplied by 4, which will give us 12. But can we simplify this further? Well, yes, we can. We can take the idea we used previously with the brackets, and we can take a factor of 2 out of the top. So we could say 2, so 2 divided by, or 2x squared divided by 2 would be x squared, minus 8 divided by 2, which would be 4, divided by, or the whole thing, y squared plus 12. But is it now possible for us to further simplify this top? We have y squared, x squared minus 4, and can we actually split this into some brackets like we did previously? So if we think of when we were making the brackets out of where we're factorizing our quadratics, we saw if we had something in the form ax squared plus bx plus c, it would be possible to simplify this out. So what we have here is we have 2 of the brackets. We'll take this down to the bottom. We can see that is x squared, which is our a, plus 0x minus 4. Okay, so now we get our 2 brackets out and we can say, right, okay, we want to find 2 sets of brackets. So we notice we have a negative, so that means we'd have a positive and a negative, so that would have to be a plus and a minus. And then we also want to get to -4. So we need something when added together equals 0, and when multiplied together equals -4. Well, there's only two numbers that can do that, and that would be 2 and 2. Therefore, we have a +2 and a -2. So we can put this back into our equation here, and in the final form, we can write the equation, the answer to the expression 2x plus 2, x minus 2, all divided by y squared plus 12. We could also take this further on to the bottom and do the same here, but for brevity, we'll leave that as it is here, and that will be the answer to our question. Okay, so next we're looking at addition and subtraction of fractions. So you may have done this before in high school and GCSE, but we're just going to reiterate what it actually is. So maybe we have something that looks a little bit like this: 3 over p plus 3 over q. Okay, so what we need to do here is find some common denominators. So how would we do this? What could we do? What could we multiply this? And what could we multiply by this separately to be able to get something we could add together? So we need a p and a q on the bottom of both of them. So what we could say is 2p divided, 2q divided by pq. So we've multiplied by q here. And we could multiply this by p, so we could say plus 3p all over pq is now we have these common denominators. Therefore, we can now simplify this problem to say 2q plus 3p is the same as p over q. So this becomes our answer. Okay. So quite simple. You might have forgotten this. This is just common denominators. I'm just touching on it briefly. Okay, so let's try something a little bit more complicated. So what happens if we get asked to simplify x minus 1 over x? Okay, right, so our first step is to realize what we actually have as a set of fractions. So x over 1 minus 1 over x. Okay, it's not divided by 0, as you remember from the first lecture. So we need some common denominators here. Well, this is quite simple. We can see it's an x. Okay, so if we multiply this by x and this by x, we get x squared divided by x not by x. So we say x squared divided by x minus 1 over x. And what we actually have here is we then have something similar as what we had previous. So we say x squared minus 1 divided by x. So it's also possible, because we had, as we saw previous, to expand this square and to factorize it into a set of brackets. So what we have is, again, if we put it into the form ax squared plus bx plus c, we see that we have 1x, we have x squared plus 0x minus 1. So we need to think of two things that can get us to 0 and when multiplied by one another equal 1. So, of course, we get our brackets out and we can see that that is x minus 1 and x plus 1. That's all it can be. Okay, so if we then put this back into our original equation, we can say our answer would be x minus 1, x plus 1, all over x, and that gives us our final answer. And finally, we'll finish off this section with a tricky question, and this will be the end of algebra before we move on to the next lecture, which will be looking at lines and applying these equations. Okay, so what happens if we have something like this? 2 divided by x plus 2 minus x. Take away 4 divided by 2x squared plus x minus 6. Okay, a real mess, something quite complicated. So what can we do here? Right, so let's begin by looking at how we can solve this. So 2 over x plus 2. So we need these common denominators. So maybe if we factorize this into some brackets, we might be able to solve this. So what have we got here? A 2x, an x, and a minus 6. So if we expand our brackets using that we have done previously, we can put we can see that there's a 2 and an x, so 1 has to be an x, so it can only be 1 times by 2, so that'd be 2x, okay. Because it's positive, they're both positive, and we need a 6 and a 1. So what could this be? Well, it would mean that we'd have to have a negative 3 and a positive 2. And that would give us, we can do a quick check, but I'm pretty confident we don't need to do the check because this fits in quite nicely. We can now say that we have x minus 4 all over x plus 2 to x minus 3. Okay, so that now means that we have a kind of common denominator, or we kind of match. So what can we do to be able to make these match really well? Well, we need to get this in. So we could multiply this 2x minus 3 by this side of the equation, this side of the expression. So we could say 2x multiplied by 2x minus 3 all over x plus 2 to x minus 3 minus x minus 4 all over x plus 2 to x minus 3. And we actually have then something we can do quite nicely. We maybe put some brackets around here, and we can then tidy this up to say that this would be 2x take 3 minus x take away 4 all divided by x plus 2 to x minus 3. Okay, so what else can we do here? Well, we could multiply this out to say that this would equal 4x minus 3 minus x minus minus x. So because we have a positive and negative multiplied by here, we have plus 4, the negative in the brackets. We can divide this all then by x plus 2, 2x minus 3. And what can we do here? Do we have anything of like terms we can take out? Well, perhaps we can take this 2 and a 3. We can tidy this up. We have a minus negative 3 and a plus 3, which negative 3, so that should be a negative 6. A negative 6 as we had 2 here. So a negative 6 and a plus 2. So that would be 4x minus x, which is 3x. And then negative 6 plus 4, which is negative 2, all over x plus 2 to x negative 3. And that is our answer. So that concludes the end of our simplification of algebraic functions, and we'll now move on to lines and logs.